Okay, we're going to continue our talk of descriptive statistics, but this time we're going to talk about how we measure sort of the spread of the data, or how we measure the dispersion of the data. And so there's a few of these that we can talk about. We can talk about the range, the variance, and the standard deviation. Okay, the range is just the difference between highest and lowest. The variance is truly the measure of the spread. Like, is it all clustered up to the middle, or is it sort of spread out over big data, like from 0 to 1,000,000, or does it just go from 0 to 5? There's a big difference there in what a variance measure. The standard deviation, that also, it's the measure of the spread, but this is what's key. It's in the same units as the data. So when I go into the calculations, you'll understand what I mean, but we typically use the standard deviation the most of these of the spread descriptors, because it's in the same units of the data. So if we do our I still am going to kind of work on this same example that I've been dealing with a few data points. Okay, so here's my example, and I have my data points 3 plus 12 plus 8 plus 16 plus 5. Okay, and I want to find, whoa, I don't know why I just added them all up. Let me erase that. What I meant to do was list the data points: 3, 12, 8, 16, and 5. Okay, so those are my data points. The range, right, is the difference between the highest and the lowest. So it's 16 minus 3, or 13. The variance is defined to be by symbol S. I put those little tails so I never think it's a 5. So S is the sum, and this is where that summation notation gets a little funky. It's x minus x bar squared over n minus 1. And the standard deviation the variance is s squared, the standard deviation is s, so check that on the s squared. Therefore, the standard deviation is just the square root of the variance. So in this example, we do need to recall that x bar was equal to 8.8. So we have our x bar, and if we do the formula for the variance, s squared, what you do there is you take each data point. So you take 3 and you subtract off the mean, and then you're going to square it. Then you're going to add to it 12, and you're going to take away the mean, which happens to be 8.8, and then you're going to square it. Then you'll take the next data point, 8 minus 8.8, and you'll square it, plus 16 minus 8.8 squared plus 5 minus 8.8 squared. And then you take all of those, and in this case we will divide by 4, or n minus 1, since from above n is 5. And when we do this computation, it is computation intensive, so it takes a while. So if you do 3 minus 8.8, you get negative 5.8, and you'll square that. Plus, if you do 12 minus 8.8, you get 3.2, and you'll square that. Plus, this is a negative 0.8, and we'll square that. And then here we have if we take 16, we get 7.2. And then if we do the 5, get the 3.8 squared all over 4. So we have that, and we keep going, keep working on our calculations, and we do negative 5.8 squared. Notice that all values inside the variance will always be positive. That's why we're squaring everything. So this is 33.64. 3.2 squared is 10.24. 0.8 squared is 0.64. Again, notice it went positive because I squared it. And then I have a 7.2 squared is 51.84. And then a 3.8 squared is a 14.44. Okay, so I do that, and I'm going to divide all of those by 4. So I get an answer there, which is 33.64 plus 10.24 plus 0.64 plus 51.84 plus 14.44. And you end up there with 110.8, and you divide that by 4. And you get 27.7. Now the problem with this is that 27.7 doesn't really mean much. Okay, so the variance is 27.7. If you take the standard deviation, which is the square root of 27.7, you get 5.26 by rounding to 2 decimal places, because our data had 2 significant digits. So our standard deviation is 5.26, and we would typically use that as a real measure of the spread of the data. I wanted to do this example so you could see one be done by hand. Of course, we do them in lab as well, where you don't compute by hand, but it's important to see all the steps of the orders of operations. Be very careful when you compute the standard deviation by hand.